Hi guys, Mrs. Young here. Today is our second day of reviewing our unit, our three-dimensional unit, and our big focus here is on surface area and volume. So this is our second day of review, and we will have one more day of review before we have our assessment, and we will be covering the assessment in 2 days. I mentioned this before. One day will be what I consider like the level 2 and 3 problems where you're doing volume and surface area, just like my bell ringer here today. And then the second day is going to be when I put the level 1 and 4s together, which I talked about in the last video. So right now, I'd like you to find the volume and surface area of these two shapes. The one on the left clearly is a triangular prism. Realize that this triangle is equilateral. So when you're trying to find the height of that triangle, right? When you try to find the height, you're aware that this is a special right triangle, 30, 60, 90. So that should help you find the height of that triangle, which you're going to use in both volume and surface area. Number 2 next door is a square pyramid. The base is a square. I'm giving you the slant height, which will be helpful in finding the surface area. But when you go to find the volume, your height isn't your slant height, it's the height perpendicular to the base. So realize that when I draw in that height, we're creating a little right triangle there. So we're trying to figure out the height of this pyramid. We know that the hypotenuse is 13. We know the short leg is half of this side, it's 5. So you've got one leg of your right triangle being 5, the hypotenuse is 13, and you have to solve for this height to use that to find your volume. So just a couple helpful hints. Go ahead and pause the video and work on your surface area and volume of these two shapes. So pause it. So for the triangular pyramid, we have a surface area. The lateral surface area is 84. And then I have the two bases, which are 8 root 3. So my total surface area is 84 plus 8 root 3. Again, pause it and look at my work if you're not sure how I got that. The volume, the area of the base times height. Again, my base is a triangle, 1/2 base times height. That's my triangle, times the height, which is 7. The triangular prism's laying down. So when you take half of 2, those two kind of cancel each other out, and then 4 times 7, I have 28, so it's 28 root 3, 28 root 3 inches cubed. For the square pyramid next door, when I'm trying to find the surface area, I got 360. So again, 1/2 times the perimeter of the base times the slant height. That's my lateral area, plus the actual base. 10 times 10 is 100, so I got 360. That was actually pretty easy for surface area. And then the last piece here for the volume, the height, we have a special right triangle. No, I'm sorry, Pythagorean triple there. This is a 5, 12, 13 Pythagorean triple, so the height of my pyramid is 12. So I have a volume of 400 feet cubed. So again, when you're finding volume, you want the actual height, which is perpendicular to the base. When we're working with surface area, you're looking at your slant height. So make sure you're aware there's a difference there. Okay. On to my next problem, or another review problem here. It says, find the surface area in terms of pi of a hemisphere with a volume of 18 pi inches cubed. So I'm going to do this one with you. If you know that the volume of a hemisphere is 18 pi, we know that the volume, let's just write down our formulas first. The volume of a sphere is 4/3 pi r cubed. So if it's a hemisphere, it's going to be half of that. So it's going to be 2/3 pi r cubed, right? Half of 4/3 is 2/3, or you could take 1/2 times 4/3 and get 4/6, which reduces to 2/3. So we can set 2/3 pi r cubed equal to 18 pi. Again, I'm trying to figure out what the radius is. Obviously, as I'm trying to solve this for r, the pi's can cancel out. I'm going to multiply both sides by the reciprocal, which is 3/2. 3/2, right? So these kind of cancel out. 6/6 is 1. On the right side, 18 divided by 2 is 9. 9 times 3 is 27. So I got r cubed is 27. I'm pretty sure you know your perfect cubes, but the cube root of 27 is 3. You could always use the calculator if you needed to, right? We talked about how to take a cube root on the calculator the other day. So I got the radius is 3. Now I want to find the surface area of this hemisphere. When you have a hemisphere, you don't need to draw the shape, but you have kind of the dome portion on top, but then you also have a circular base, right? So there's kind of two parts to the surface area of a hemisphere. So you've got half of the surface area of a sphere. Well, the surface area of a sphere, maybe I'll write that one down too. The surface area of a sphere is 4 pi r squared. So if we have a hemisphere, that's half of it, that's 2 pi r squared. But then we also have this circular base. Well, we know the area of a circle is pi r squared. So really, the surface area of a hemisphere is 3 pi r squared, right? You got 2 pi r squared plus 1 pi r squared gives us 3 pi r squared. So if I know the radius is 3 times pi times 3 squared. Well, 3 squared is 9. 9 times 3 is 27. So 27 pi is my surface area of the hemisphere. Think about it. Make sure you know how to do this. This is a relatively easy problem, but we're first trying to find the radius given volume, and then use that to find surface area. I'm going to have you guys try one similar to this, but with some different numbers. So find the surface area in terms of pi of a sphere with a volume of 36 pi. So again, this time we're just dealing with a sphere, not a hemisphere. So go ahead and pause the video and try to find the surface area in terms of pi of a sphere with a volume of 36 pi. Pause it. So I got a surface area of 36 pi. Again, that's kind of ironic because the volume was 36 pi and the surface area is also 36 pi. And I'm pretty sure that's only going to happen when the radius is 3. I think this is the only situation where the volume and the surface area for a sphere are the same. So again, I set 36 pi equal to 4/3 pi r cubed, the volume of a sphere. The pi's canceled out, multiplied by the reciprocal. Again, I still got a radius of 3. So then when I plug that into my surface area formula, 3 squared is 9. 9 times 4 is 36. I get 36 pi. So that one's pretty easy. And I'm guessing there'll be one like that on our assessment. The next one that I'd like you to try, this one's a little bit easier. This is just a square pyramid. So just like the square pyramid in the bell ringer. Again, I'm giving you a slant height here of 41. That's going to help you for surface area. But then when you're trying to find the volume, you're going to have to figure out the actual height. And again, notice that you have a right triangle there, and think back to that bell ringer problem that we just did. So go ahead and pause the video and see if you can find the volume and surface area of this square pyramid. So pause it. Okay, so for my volume, 1/3 times the area of the base times the height. The base is a square, 18 times 18. My height, again, we've got a right triangle here. If my hypotenuse is 41, this short leg is half of the side of that square, so half of 18 is 9. So this is actually a Pythagorean triple, 9, 40, 41. I think we mentioned that once before, but if you didn't remember that, you could just use Pythagorean theorem to figure out that missing leg, which gives you your height. So your volume should be 4,320 centimeters cubed. For my surface area, again, this was pretty easy. 1/2 times the perimeter of the base, 4 times 18 is 72, times the slant height, which is 41. So we got 1476 for the lateral. And then the area of the base, 18 times 18, that's 324. And when I add those together, I get a total surface area of 1,800 centimeters squared. Again, just notice that for surface area, your units are squared, and volume, your units are cubed. So I'm guessing, you should know how to find volume and surface area of a lot of different types of shapes. Next, we're going to practice something, a couple problems that I consider kind of our level 4-ish. This is like a composite figure. So this would be like a level 4 on our assessment. It's a composite figure, and you're trying to find the surface area and the volume. So notice that you have what looks like kind of like a box rectangular prism with a half cylinder on top. So it's like they took a box and stacked a half cylinder on top. So for surface area, you want to find the area of all the surfaces and add them together. And then volume, you're going to find the volume of the rectangular prism, right? And then add to it the volume of the half cylinder. Remember, it's a half cylinder. Things I want to point out too, if this whole side is 6, then we know that the radius of that circle is half of that, it's 3. And that means also that this is 3 right here, right? So the radius all the way around is 3 on that half cylinder. Also remember, because it's a composite figure, that it's hollow in the middle. So I think hopefully the rectangular prism part's going to be easy. Be careful on your half cylinder. So go ahead and pause the video and see if you can find both the surface area and volume. And again, round to the nearest tenth. On our assessment, we're generally going to be rounding to the nearest tenth for most of our answers. So I'm going to start with volume. I always think that's the easier one. So the volume of the box, the rectangular prism, that's 2 by 6 by 10. So that rectangular prism has a volume of 120. My half cylinder, a cylinder is pi r squared h. Half of that is half pi r squared h. Like I mentioned before, this is half of that, so my radius is 3. So I get a half cylinder volume of 45 pi. So if I had said exact answer, you would have said 120 plus 45 pi, but rounded to the nearest tenth, that's 261.4. The other thing that we want to talk about is surface area. Again, for the prism at the bottom, the lateral, that's all the way around 32. That's the perimeter of the base times the height, which is 2. So the lateral of that prism is 64. And then I only have a bottom surface there, 6 by 10 at the bottom, that's 60. There's no top on that rectangular prism, right? So there's my surface area of the 5 sides of my rectangular prism. For my half cylinder, I've got pi r squared plus pi r h. So when I add those together, I get 39 pi. And then when I add all 3 of those together, I get 246.5. Okay, next problem. Pause it and look at that if you need to. Next problem is another composite figure. We have a rectangular prism with a triangular prism stuck on the bottom this time. Again, you want to find the volume and surface area. Volume is going to be a little bit easier. Find the volume of the rectangular prism and then the volume of the triangular prism. Add the two together. Surface area, find the area of each of the surfaces and add them together. A few things I can point out to you. If this is 8, there's a tick mark here, so this is also 8, and this is 8, and then I know that this is 9. So if you added together 8 plus 9 plus 8, that would give you this whole side of that box. That might be helpful. Also, when you're working on surface area, the side of the triangular prism that's kind of hidden back there, you're going to need to figure out the length of this piece right here, but I can see that I've got a right triangle, right? So if this is 17 and this is 9, you should be able to figure out what that is. You're probably going to use Pythagorean theorem to figure out the length of that side, which will give you this rectangular piece, the left side of that triangular prism. So surface area is a little bit trickier here. Again, if this were a traditional assessment, this would be like our level 4 type problem. So again, I'd like you to pause it and take your time and see if you can find the volume and the surface area of this composite figure. Okay, so for my volume, the volume of the box, so that's just going to be 8 by 7 by 25, right? So that's 1400 for the volume of the box. The volume of the triangular prism, that's the area of the triangle times the height. So a triangle is 1/2 base times height. So 1/2 9 times 17 times the height, which is 7. So that gives me the volume of that triangular prism. And then when I add those two together, I get a volume of 1935.5. So again, volume usually is a little easier. Surface area, a little bit trickier. For my box, I kind of broke it down into the different pieces of the box. I've got the right side and the left side, right? 7 times 8 times, there's 2 of those, 112. I have the front, which is 8 by 25, and also the back, which is 8 by 25, right? So again, I have 2 of those. That gives me, I don't even see, I think I erased it. Whoops. And then the top, I have 25 by 7. So that's the top surface. But on the bottom, because it's hollow in the middle, I just have 2 rectangles here. I have an 8 by 7 rectangle on the left side and then an 8 by 7 rectangle on the right side. So those 2 rectangles are on the bottom side of that box. So I have a total surface area there of 799. And again, I apologize, I must have erased that one number. For my triangular prism, the right side, this is 7 by 17, this rectangle, 119. The left side, again, I did Pythagorean theorem to find out that missing side. So it's the square root of 370 times 7. That's going to give me this kind of slanty left side of that triangular prism. And then I've got the front and the back. So the front and the back are two triangles. So 2 times, again, a triangle is 1/2 base times height. So 1/2, 9 times 17. So I got 153. So again, I've got the right side, the left side, the front and back. And then when I add those together, I got 406.647, dot, dot, dot. So that's the surface area of my triangular prism. When I add together the surface area of the box and the triangular prism together, I should have a total surface area of 1205.6. So again, surface area is definitely more challenging, I think, in most situations or most problems. Our homework for tonight, oh gosh, I didn't even think of this. Our homework for tonight is from our packet. I am making it a little bit shorter for you. So it's pages 51 and 52, 19 through 41, just the odd. So 19 through 41 odd. Again, these are the last, not the last, but the second to last 2 pages out of your packet, 19 through 41 odd. So that's your homework for tomorrow. And again, we're going to continue this review one more day, a little bit more review of surface area and volume before we have our assessment. And again, we are taking this assessment over 2 days. If we were in school, in the classroom, you do it in 1 day, but I'm kind of breaking it up and making it a little bit more manageable for you during our distance learning. Okay, have a good one. Do your homework. Stay healthy, guys. Bye.